Hey everyone, welcome back to the deep dive. Don't forget to hit that like button and subscribe to the channel and click that bell icon so you don't miss any of our deep dives.
Today we're going really small, like really, really small. We're talking about the nanoscale. And for all you future geniuses out there prepping for those UPSC exams, this one's for you. We're going to be tackling nanoscience, nanotechnology, A&D, nuclear science, all super important topics in the GS3 syllabus. But you know what? Even if you're not studying for exams, this stuff is seriously cool. We're talking revolutionizing medicine, cleaning up the environment, even changing the way we get our energy. Like, it's mind-blowing.
Yeah, it's pretty amazing what happens when you start looking at things at the atomic level.
I know, right? So let's break this down a little. What exactly is nanoscience?
Well, you know how a meter stick is. Okay, so imagine that meter stick was the size of the whole planet. A nanometer would be about as big as a marble. That's how small we're talking.
Yeah.
1/1000th of a meter. Wow. Okay, so that's nanoscience, looking at the itty-bitty stuff. But what about nanotechnology? Is that where we actually start building things with these nano-sized pieces?
Exactly. It's like engineering, but on a molecular level. Imagine creating materials 10 times stronger than steel, but super light. Or tiny robots that can deliver medicine right to a sick cell.
Ooh. Okay, that's some next-level stuff.
Yeah.
So before we get into all the amazing things nanotech can do, I'm curious about these nanomaterials. What are the superstars of this tiny world?
Oh, well, the carbon-based nanomaterials are definitely the cool kids on the block. They're just different ways you can arrange carbon atoms, but each one has totally unique properties, makes them super versatile.
Wait, so carbon, the same stuff in diamonds and pencils, that's what's driving this nanotech revolution?
Yep. Take fullerenes, for example. They're nicknamed buckyballs because they look like those geodesic domes. They're made of 60 carbon atoms in this hollow sphere. And get this, scientists are actually looking into using them to deliver medicine directly to the brain.
You're kidding. Tiny carbon balls going through our brains to deliver medicine. That's wild. What other carbon nanostructures are out there doing cool things?
Oh, well, there are carbon nanotubes. Imagine taking a sheet of graphene, which is just a single layer of carbon atoms arranged in a honeycomb pattern, and rolling it into a tube. These things are unbelievably strong, like 100 times stronger than steel, but only 1/6 the weight.
So you're saying we could have super strong but lightweight materials for buildings, bridges, even spaceships?
Exactly. And that's not all. Carbon nanotubes can also act as tiny sensors. Imagine a sensor that can detect a single molecule of a pollutant in our water. We could catch contamination problems before they even start.
Now that's some seriously impressive stuff.
Nah.
Okay, so what about graphene itself? What makes this single layer of carbon atoms so special?
Graphene is pretty amazing. It's the thinnest and strongest material we've ever found. Plus, it's flexible, transparent, and conducts electricity and heat like a champ. We could have flexible electronics, super efficient solar panels, even faster computer chips. The possibilities are endless.
It's hard to believe something so thin can be so powerful. Are there any other nanomaterials we should be keeping an eye on?
Oh, definitely. It's not just carbon. We've got the whole periodic table to play with. Take zeolites, for example. They're porous minerals that act like tiny sieves, grabbing specific molecules. People already use them in water purification, laundry detergent, all sorts of things. And scientists are even looking at using them to capture carbon dioxide from the air to fight climate change.
Wow, so these little mineral cages could help clean up the planet. That's fantastic.
And then there are dendrimers. These are like tiny trees made of polymers with tons of branches. All those branches give them a huge surface area, which is perfect for delivering drugs right where they're needed. Think of them as tiny packages carrying medicine directly to specific cells. Less side effects, better treatments. They're also being used to clean up the environment, like removing heavy metals from contaminated water.
It sounds like the possibilities with nanotech are pretty much limitless. But before we get too carried away, I think we need to talk about the potential downsides. I mean, we're talking about manipulating matter at the atomic level. Do you think there are some safety concerns?
Oh, absolutely. With any powerful technology, we have to be careful. One big concern is that these nanoparticles are so tiny, they could get into our bodies and interact with our cells in ways we don't fully understand yet. Scientists are definitely working on figuring out the risks and making sure we develop safe nanomaterials.
So it's a delicate balance. While we're unlocking all this incredible potential with nanotechnology, we have to be mindful of the risks and make sure we're using it responsibly.
Exactly. We need to be smart about how we use this technology so we can really make the most of it.
This has been a fascinating look into the nano world. It's amazing how these tiny particles have the potential to make such a huge impact on our lives. Now let's switch gears a little bit and talk about another field where we're dealing with the building blocks of matter, nuclear science. It might seem like a big jump from the nanoscale to the atomic scale, but there are some interesting connections.
Yeah, you're right. In both nanotech and nuclear science, we're trying to understand and manipulate the tiniest parts of matter, just at different levels, and both have huge potential to solve some of humanity's biggest problems, whether it's energy or healthcare.
So let's start with the basics. When we talk about nuclear science, we often hear about radioactivity. What exactly makes an atom radioactive?
Well, it all comes down to the nucleus of an atom. You see, the nucleus has protons and neutrons. And some combinations of these particles are just naturally unstable. So these unstable nuclei will spontaneously decay, releasing energy in the form of particles or radiation as they try to reach a more stable state.
So it's like they're trying to shake off some extra energy to get more comfortable.
Right. That's a great way to think about it. And the speed at which they decay is called their half-life. It's the time it takes for half of those radioactive atoms in a sample to decay. Some radioactive isotopes have really short half-lives, like minutes or hours, while others can stay radioactive for thousands or even millions of years.
And understanding that half-life is super important when we talk about things like nuclear waste, right?
Yeah.
Especially how long it stays dangerous.
Mhm.
Okay, so when we talk about the power of the atom, we often hear about fission and fusion. Can you break down the difference between those two?
Sure. Nuclear fission is when you split a heavy atomic nucleus, like uranium or plutonium, into lighter nuclei. And when you do that, a huge amount of energy is released. Imagine breaking a stick in half, but instead of just two pieces, you get a ton of energy released too.
So that's the process that powers nuclear power plants, right?
Exactly. Nuclear fission is an amazing way to generate electricity. But of course, there are challenges too, like what to do with the radioactive waste and making sure those nuclear reactors are super safe.
And fusion, isn't that what powers the sun?
You got it. Nuclear fusion is when you take two light atomic nuclei, usually hydrogen isotopes, and fuse them together to make a heavier nucleus. This releases even more energy than fission. It's the ultimate clean energy source. Abundant fuel, no greenhouse gases, and very little long-lasting radioactive waste.
Okay, so if it's so great, why aren't we all using fusion power already? It sounds like the perfect solution.
Well, there's a catch. It's really hard to do controlled nuclear fusion. You need to create temperatures and pressures similar to the core of the sun, which is a huge technological challenge. We're getting there, but we're not quite there yet.
So it's like trying to create a miniature sun here on Earth. But the potential payoff is huge. Clean and almost unlimited energy.
So let's talk about how we currently use fission to generate electricity in those nuclear reactors. Can you explain how a nuclear reactor works? Sure. Think of a nuclear reactor as a carefully controlled environment where we can start and maintain a chain reaction of nuclear fission. We use fuel rods that contain uranium, and when a neutron hits a uranium nucleus, it splits, releasing energy and more neutrons. Those neutrons go on to hit other uranium nuclei, causing them to split, and so on. It becomes this self-sustaining chain reaction.
It's like a carefully choreographed dance, but with atoms, and each step releases energy.
That's a great analogy. And then that energy is used to heat water, which makes steam, and that steam drives turbines to generate electricity. The whole process is carefully controlled. We use things called moderators to slow down the neutrons and control rods to absorb them so the reaction doesn't get out of control.
It's incredible how we've learned to control this powerful force of nature to create electricity. Now, I know there are different types of nuclear reactors, each with its own pros and cons. Can you give us a quick overview?
Of course. The most common types are pressurized water reactors, or PWRs, and boiling water reactors, which we call BWRs. They both use regular water to cool and moderate the reactions. Then there are CANDU reactors. Those were developed in Canada, and they use heavy water, which means they can run on natural uranium fuel. And then there are fast breeder reactors, or FBRs. These are designed to create more fuel than they use. They could really extend how long we can use nuclear fuel.
It's fascinating how many different approaches we've developed to use nuclear energy. Now, shifting gears a bit, let's talk about India. I know our country has a big and ambitious nuclear program. Can you give us an overview?
India's nuclear program is really unique. We want to achieve energy security and be self-reliant in terms of technology. We have a 3-stage nuclear power program. The goal is to use our huge thorium reserves, which are some of the biggest in the world.
Right. I remember learning about that 3-stage program in school. Can you remind us what each stage is all about?
Absolutely. The first stage, which is the backbone of our nuclear power right now, uses pressurized heavy water reactors, those PHWRs I mentioned, that use natural uranium as fuel. The second stage is all about those fast breeder reactors, the FBRs, that actually create more fuel than they use. That lets us use our massive thorium reserves. And the third stage, which is still being researched and developed, focuses on thorium-based reactors. That's when we'll really be able to use all of that thorium.
It's incredible how India is making its own path in the nuclear world, with the goal of becoming energy independent. But with great power comes great responsibility, right?
hmm
I imagine safety and regulations are super important when it comes to nuclear energy.
You're absolutely right. India has a really strong system to make sure nuclear technology is used safely and responsibly.
That's great to hear.
Yeah.
It sounds like India is taking a careful and responsible approach to nuclear safety. Now let's zoom out a bit and talk about India's role on the global nuclear stage. I know India has a unique stance on nuclear nonproliferation. We haven't signed the Non-Proliferation Treaty, the NPT.
That's right. India has always said that the NPT is unfair. It creates a world where some countries have nuclear weapons and others don't. However, even though we haven't signed the NPT, India is totally committed to nonproliferation. We've voluntarily stopped nuclear testing and we strictly follow international safeguards.
So India is walking the walk, showing responsible behavior with nuclear technology, not just talking about it.
Exactly. And to make sure everyone knows we're serious about transparency and international cooperation, India signed the Comprehensive Safeguards Agreement with the International Atomic Energy Agency, the IAEA. This agreement means the IAEA can inspect many of our civilian nuclear facilities to make sure they're only being used for peaceful purposes.
That's a big step toward building trust with the rest of the world. Speaking of international cooperation, I remember the India-US Civil Nuclear Agreement. It was a big deal a few years ago. Can you tell us about that?
The India-US Civil Nuclear Agreement, signed back in 2008, was definitely a turning point. It meant that India was no longer isolated in the nuclear world and could finally start trading nuclear technology and materials with other countries. We can now import nuclear fuel and technology, which is really important for growing our nuclear program.
It sounds like that agreement really opened up a lot of possibilities for India in the global nuclear world.
Absolutely. Now we can participate in the global nuclear market and work with other countries on cutting-edge research and development in nuclear energy. This access to advanced technologies is essential for India to achieve its clean energy goals.
Now, we talked earlier about India's interest in developing thorium-based reactors. Are we collaborating with other countries on that?
Yes, we're actively involved in a lot of international efforts to develop thorium-based reactor technologies. One great example is our participation in the International Thermonuclear Experimental Reactor Project, or ITER.
Ah, ITER. That's the massive fusion energy project in France. It's such a remarkable undertaking.
It really is. ITER is a huge collaborative project with 35 countries involved, including India. We're all working together to show that fusion power is possible. And even though ITER is primarily about fusion, it can also help with using thorium. Some fusion reactor designs could be adapted to create fissile uranium-233 from thorium, which would be a game changer for India's energy future.
So India is not only focused on our own goals, but also contributing to global efforts in advancing nuclear science and technology. That's fantastic.
International cooperation is so important in nuclear science, especially when we're trying to tackle global challenges like climate change and energy security. India gets that and is actively participating on the world stage.
Now, before we move on from nuclear science, I wanted to touch on another really interesting area, how it's used in medicine. I know radioactive isotopes are used in all sorts of medical procedures. Can you tell us more about that?
Nuclear medicine is a really cool field that uses radioactive isotopes or radioisotopes to diagnose and treat lots of different diseases. These radioisotopes emit radiation that we can detect and create images from. It gives doctors a window into what's happening inside the body.
So it's like using tiny radioactive trackers to see what's going on inside us.
That's a great way to put it. For example, with diagnostic imaging, we can attach small amounts of radioisotopes to molecules that target specific organs or tissues. Then special cameras pick up the radiation from those radioisotopes and create images that help doctors diagnose things like heart disease, cancer, bone problems, even neurological disorders.
It's like having X-ray vision, but at a molecular level.
Exactly. These images can show the structure and function of organs and tissues, so doctors can find abnormalities and make more accurate diagnoses.
And what about treatment? How are radioisotopes used for that?
In treatment, radioisotopes are used to deliver targeted radiation that can kill cancer cells or shrink tumors. There are a few ways to do this. Sometimes we inject the radioisotopes directly into the tumor. Other times we use special antibodies that are labeled with radioisotopes, and these antibodies seek out and attach to cancer cells specifically.
So it's like sending tiny guided missiles to attack the cancer cells while trying to avoid harming the healthy cells. That's incredible.
It really is. Nuclear medicine is a powerful tool in the fight against cancer and many other diseases. And as this field keeps advancing, we're seeing more and more innovative treatments.
This has been such an eye-opening journey through the worlds of nanoscience, nanotechnology, and nuclear science. It's clear that these fields aren't just about scientific exploration. They have the potential to make people's lives better and address some of the biggest challenges facing our world.
I totally agree. We've seen how these fields can revolutionize medicine, help us understand the human body better, and offer sustainable solutions for our energy needs. And as research and development continue, we can expect even more amazing applications to emerge.
It's inspiring to think about all the possibilities. But before we wrap up this deep dive, I want to highlight a few key takeaways. First, we've learned that the world of the ultra-small is full of surprises. Materials behave in completely different ways at the nanoscale, which leads to some incredible properties we can use to create amazing new materials and devices.
And we can't forget those carbon-based nanomaterials. From those versatile buckyballs to the super strong carbon nanotubes and the remarkable graphene, they're already being used in all kinds of fields, and there's no telling how far they'll go.
And then there's the incredible power of the atom. Nuclear science has given us the ability to generate clean energy and develop life-saving medical treatments. But it also comes with responsibility, reminding us that we need to ensure the safe and responsible use of nuclear technology.
Absolutely. And with its ambitious three-stage nuclear program, India is becoming a major player in the world of nuclear science. We're working towards energy independence and playing a crucial role in international collaborations, pushing the boundaries of scientific knowledge and technological innovation.
This deep dive has really shown the ingenuity and boundless curiosity of humans. And as we keep exploring the frontiers of science, who knows what incredible discoveries and breakthroughs are waiting for us?
The future is full of possibilities, so stay curious, never stop learning, and who knows, maybe you'll be the one making those groundbreaking discoveries that shape the future.
Until next time, keep diving deep.
And we're back. Before the break, we were talking about India's awesome journey towards energy independence with its three-stage nuclear program.
Yeah, it's seriously impressive how India is planning for a sustainable energy future. But you know what they say? With great power comes great responsibility. Safety and regulations must be super important when it comes to nuclear energy.
Oh, absolutely. India has a really strong system in place to make sure we're using nuclear technology safely and responsibly. The Department of Atomic Energy, the DAE, is the main organization responsible for developing and using nuclear energy. And then there's the Atomic Energy Regulatory Board, the AERB. They're like the independent watchdog, making sure that all of our nuclear facilities meet the highest safety standards.
So it's like a two-pronged approach. DAE leading the way, AERB making sure everything's safe and sound.
Exactly. The AERB sets safety standards, does really thorough inspections, and gives out licenses for operating nuclear power plants. They make sure everything's up to par with international guidelines.
That's definitely reassuring to know. Okay, so it seems like India is taking a really comprehensive and responsible approach to nuclear safety. Now let's zoom out a little and talk about India's place in the global nuclear landscape. India has a unique stance on nuclear non-proliferation. We haven't signed the Non-Proliferation Treaty, the NPT.
That's right. India has always maintained that the NPT is discriminatory. It basically creates a world of nuclear haves and have-nots. But even though we haven't signed it, India is totally committed to non-proliferation. We voluntarily stop nuclear testing, and we follow international safeguards really strictly.
So India is walking the walk, showing the world that we're responsible with nuclear technology, not just talking about it.
Exactly. And to show that we're serious about transparency and cooperation, India signed the Comprehensive Safeguards Agreement with the International Atomic Energy Agency, the IAEA. That means the IAEA can inspect a lot of our civilian nuclear facilities to make sure we're only using them for peaceful purposes.
That's a huge step in building trust with the international community. Speaking of international cooperation, I remember the India-US Civil Nuclear Agreement being a pretty big deal a few years back. Can you tell us more about that?
Oh yeah, the India-US Civil Nuclear Agreement, signed back in 2008, was definitely a game changer. It basically marked the end of India's nuclear isolation and opened the door for us to trade civilian nuclear technology and materials with other countries. Now we can import nuclear fuel and technology, which is crucial for expanding our nuclear power program.
It sounds like that agreement really changed things for India in the global nuclear scene.
Absolutely. We can finally participate in the global nuclear market and collaborate with other countries on cutting-edge research and development. We need access to advanced technologies to reach our clean energy goals.
We talked earlier about India's interest in developing those thorium-based reactors. Are we working with other countries on that?
Definitely. We're involved in lots of international projects focused on advancing thorium-based reactor technologies. One big one is our participation in the International Thermonuclear Experimental Reactor Project. You probably know it as ITER.
Ah, ITER. That massive fusion energy project being built in France. What an amazing undertaking.
It really is. ITER is a huge collaboration involving 35 countries, including India. We're all working together to prove that fusion power is actually possible. And you know what? Even though ITER is mainly focused on fusion, it could have some implications for using thorium, too. Some fusion reactor designs can be tweaked to create fissile uranium-233 from thorium. That would be a game changer for India's energy future.
So India is not just focusing on our own national goals, we're also contributing to global efforts in nuclear science and technology.
Yep, international cooperation is so important, especially in nuclear science. We need to work together if we're going to tackle global challenges like climate change and energy security. India understands that, and we're doing our part on the world stage.
Now, before we move on from nuclear science, I wanted to touch on another super interesting application, nuclear medicine. Radioactive isotopes are used in so many medical procedures, right?
Right. Nuclear medicine is an amazing field that uses radioactive isotopes, sometimes called radioisotopes, to diagnose and treat tons of diseases. These radioisotopes emit radiation that we can detect and use to create images, which basically gives us a peek inside the human body.
So it's kind of like using tiny radioactive beacons to see what's happening inside us.
Exactly. Take diagnostic imaging, for instance. We can attach a tiny amount of a radioisotope to a molecule that targets a specific organ or tissue. Then we use special cameras to detect the radiation coming from that radioisotope and create images that help doctors diagnose all sorts of things like heart disease, cancer, bone problems, even neurological disorders.
It's like having molecular level X-ray vision.
Pretty much. We can see the structure and function of organs and tissues, which helps doctors find any abnormalities and make better diagnoses.
That's amazing. And how are radioisotopes used in treatments?
For treatment, radioisotopes are used to deliver very targeted radiation that can kill cancer cells or shrink tumors. There are a couple of different ways we do this. Sometimes we inject radioisotopes directly into the tumor. Other times we use antibodies that are labeled with radioisotopes, kind of like little homing missiles, that specifically target and attach to cancer cells.
So it's like sending in a tiny army to attack the cancer cells directly while trying to minimize damage to healthy tissue. That's incredible.
Yeah, nuclear medicine is a powerful tool in the fight against cancer and many other diseases. As the field keeps advancing, we're seeing more and more innovative treatment options.
This has been such an amazing journey through the worlds of nanoscience, nanotechnology, and nuclear science. These fields aren't just about scientific exploration. They have the potential to make people's lives better and solve some of the world's biggest problems.
Absolutely. We've seen how they can revolutionize medicine, help us understand the human body better, and give us sustainable solutions for energy. And as research and development continue, I'm sure we'll see even more amazing applications come out.
It's pretty inspiring to think about all the possibilities. But before we wrap up this deep dive, I want to highlight a few key takeaways. First, we've learned that the world at the nanoscale is full of surprises. Materials act completely differently at that level, and that leads to some incredible properties that we can use to create amazing new materials and devices.
And we can't forget those awesome carbon-based nanomaterials, those versatile buckyballs, those super strong carbon nanotubes, and that wonder material, graphene. They're already being used in tons of fields, and who knows how far they'll go.
Right. And then there's that mind-blowing power of the atom. Nuclear science has allowed us to generate clean energy and develop life-saving medical treatments. But it's a reminder that we need to be careful and responsible when using this technology.
Absolutely. And India is stepping up to the plate. With our 3-stage nuclear program, we're becoming a leader in the world of nuclear science, working towards energy independence and playing a key role in international collaborations, pushing the boundaries of what we know and what we can do with this technology.
This deep dive has been a testament to human ingenuity and our never-ending curiosity. Who knows what incredible discoveries are still out there, waiting to be uncovered as we continue to explore the frontiers of science.
The future is full of possibilities, so stay curious, never stop learning, And who knows, maybe you'll be the one making those groundbreaking discoveries that shape the world.
Until next time, keep diving deep.
And we're back for the final part of our deep dive.
We've been exploring the incredible worlds of nanoscience, nanotechnology, and nuclear science. It's been quite a journey, hasn't it?
It really has, from manipulating those tiny atoms to harnessing the immense power of the nucleus. We've seen some incredible scientific advancements and the potential for amazing breakthroughs.
It's mind-blowing to think about what the future holds. But before we wrap things up, I think we should talk about the bigger picture, the implications of these technologies. We talked about some of the risks with nanotechnology, like the potential toxicity of nanoparticles and the need to be responsible as we develop these technologies.
You're right. With any powerful technology, we need to be cautious and think ahead. We need to understand the potential downsides so we can put safeguards in place. Develop regulations to minimize risks and make sure nanotechnology is developed ethically and sustainably.
So it's an ongoing process, right? Research, evaluation, responsible innovation.
Exactly. It has to be a collaborative effort. Scientists, policymakers, industry leaders, and the public all need to work together. Open communication and a shared commitment to responsible innovation. That's how we can harness the power of nanotechnology and use it for good.
Okay, so let's switch back to nuclear science for a minute. We talked about India's commitment to non-proliferation and the strict safety measures we have in place to make sure nuclear technology is used responsibly. But in a world where there are so many security concerns, how do we prevent nuclear materials from falling into the wrong hands?
Nuclear security is a top priority for India and the whole world. We have a multi-layered security system to protect our nuclear facilities and materials. Physical protection, strict access controls, constant surveillance. It's a comprehensive approach.
Sounds like you've got all the bases covered.
We do our best, and it's not just about what we do here in India. We also work closely with other countries to strengthen global nuclear security, sharing best practices and working together to make sure everyone is doing everything they can to keep nuclear materials safe.
So it's a global effort, a shared responsibility to make sure this technology is only used for good.
Absolutely. We can't afford to take any chances. The consequences of nuclear materials falling into the wrong hands are just too serious.
Well, this has been a truly fascinating deep dive, a testament to the power of science and technology to shape our future. It's also a reminder that we have to use these powerful tools responsibly and wisely.
I couldn't agree more. It's all about balance, using innovation to make progress while protecting humanity and our planet.
And that brings up another really important point: public awareness and education. These are complex topics, often full of technical jargon, and it's important that people have access to good, reliable information so they can make informed decisions.
I completely agree. We need to break down these complex ideas and get people talking about the benefits, the risks, and the ethical implications of these powerful technologies.
And that's exactly what we try to do here on the Deep Dive. Make complex topics accessible and engaging so our listeners can be part of the conversation and help shape the future.
It's been great sharing what we know with you today. I hope this deep dive has sparked your curiosity and given you a better understanding of the amazing worlds of nanoscience, nanotechnology, and nuclear science.
And remember, everyone, the journey of discovery never ends. Keep that curiosity alive, keep exploring, and who knows, maybe you'll be the one making the next groundbreaking discoveries. Until next time, keep diving deep.